Assalamualaikum and hi, Chapter 3 Numerical Method. In this video, we will learn Chapter 3.1 Solutions of Nonlinear Equations. The learning outcomes for this video is to locate approximately a root of an equation by graphical consideration. Many equations cannot be solved exactly. For example, if we have equation x cubed minus exponent x equals to 0, if we rearrange this equation, we will get x cubed equals to exponent x. Or if we have cos 2x equals to x. These are some of the examples of the equation that cannot be solved, but various methods of finding approximate numerical solution exist. As you can see here, the most commonly used method have two main parts: finding an initial approximate value and to improve this value by an iterative process. So what is the initial value? The initial value of the roots of fx equals to 0 can be located approximately by either a graphical or an algebraic method. In this video, we will learn how to find the initial value by using graphical method. So this is how we use graphical method. If you have one function, let's say y equals to fx, the real roots are the point where the curve cuts the x-axis. And if you have two functions, let's say fx or gx, the real roots are at the points of intersection between two graphs. If the question asks you to show if the real root exists, what you have to do is first to sketch the graph, and the second one is to write the conclusion. So your conclusion will include if there is a point of intersection or if there is a point that cuts the x-axis. Let's take a look at the first example. The question asks to find the root of the equation y equals to x cubed by using the graphical method. As we know earlier, we have to sketch the graph. So we have graph y equals to x cubed. Then we have to sketch graph cubic. This is graph cubic. So we have, this is the basic shape of cubic graph. So we have cubic graph here. So we know that the real root are the points where the curve cuts the x-axis. So the curve cut x-axis at x equals to 0. So we can write the conclusion, the roots is x equals to 0. So that is how you determine the root of the equation. Let's see example 2. The question asks to show that there exists a real root between 1, 4 for the equation ln x plus x minus 4 equals to 0 by using the graphical method. So as you know, we have the equation ln x plus x minus 4 equals to 0. So what we have to do is we have to rearrange this equation. So we have ln x equals to 4 minus x. So you will have two equations, y1 equals to ln x and y2 equals to 4 minus x. So from both of these functions, we have to sketch graph on the same axis. So we have x-axis, y-axis. So the first function is y1 equals to ln x. So we know the shape of the graph y1 equals to ln x is like this. So we have y1 equals to ln x. And we have y2 equals to 4 minus x. So this is graph y2 equals to 4 minus x. So from previous slide, we know that the real roots are the points of intersection between two graphs. The point of intersection between two graphs. So, as you can see from the graph that we draw here, there is one intersection point between x-intercept 1 and 4. This is the root. The question asks you to show, so what we have to do is we have to write the conclusion. Since there is one intersection point, there is a root lies between 1 and 4.